Find the area of the surface generated by revolving the curve x equals y cubed over 8 from 0 to y, 0 less than y less than 2 about the y-axis. Okay, the area of the surface area is in square units. All right, so first thing I'm going to do is write down the equation y cubed over 8, 0 less than or equal to y less than or equal to 2. And since I don't intuitively understand things written in terms of y, I'm just going to flip it around. So we're going to say y cubed equals 8x, square rooting both, cube rooting both sides. We're going to get 2x to the 1/3. Okay. Now I'm going to draw a picture because pictures are nice. I like pictures. So y equals x, the cube root of x is kind of like square root. So it kind of has the same feel to it. So let's say like that. And yes, we'll go from 0 to 2. So we're going to revolve this around like that, and we're going to get kind of like a funnel shape here. Yeah, that seems reasonable. I'm going to go from 0, y equals 0 to y equals 2. And we're going to do, so what I'm going to do is I'm going to look at a small section of this. I'm going to use specifically that section right there. It doesn't really matter. And it's going to be height of dy. And so this section is going to look like this. And what we're going to do is we're going to find the area of this section right here, the area. And we're going to integrate that area from the bottom to the top. So we're going to do from y initial, which is 0, to y final, which is 2, of a small bit of area. Yes, that's exactly what we're going to do. All right, and then the area of this section here, we're going to do this kind of like a circle. So it's going to be 2 pi r. So 2 pi r is going to be, this will be r. That's going to be the area of the circle. So we're going to say this is a cylinder. But the cylinder, the length of the side isn't delta y. The length of the side is going to be delta L. It's going to be kind of a funny shape there. So it's going to be 2 pi r delta L. Delta L is the arc length. You might think like, well, if it's really small, it kind of is the same. No, we can't actually do that. I understand the feeling, but that's not going to work. So we're going to have to do like the hypotenuse here, which is exactly what we're going to do next. So we're going to look and see, all right, what is delta L? So I'm going to say that delta L is just the hypotenuse. So I'm going to say delta L squared is going to be delta x. So this will be delta x right here. Squared plus delta y squared. Square rooting everything and simplifying a little bit, we get delta x squared plus delta y squared. Dividing both sides by delta y. In fact, basically we're going to factor out a delta y. So we get delta x squared, delta y squared plus 1 times the square root delta y squared. Simplifying this one more time, we get square root of dx dy plus 1. This will be squared. The square root of delta y, I'm just going to say, is dy. And this is going to be, I know I'm kind of mixing up deltas and d's. Delta is a very small segment. Delta d, the actual d, is the derivative, an infinitely small segment. I'm interchanging them, kind of abusive notation. I apologize. Anyway, long story short, delta L, small l, is this. And this is just going to be similar to the arc length formula. I just tend to derive it every time because I have the memory of a goldfish. It's pretty much non-existent. So dA, a little bit of area, is going to be 2 pi r. And I'm also going to say over here, r is going to be this distance right here, which when we look up here, we can tell that r, this r, is equal to x, which we know is y cubed over 8. Y cubed over 8. So r equals x, which equals y cubed over 8. Plugging this in up here, I know, not very linear in my thought process. I should be cleaner in this. Okay, 2 pi r, which is the same as x, which is the same as y, is going to be y cubed over 8 times the square root. So delta L is the square root of dx dy quantity squared plus 1 times, I'm going to say delta y. Okay, so now it looks like everything's kind of come together. We need to find out what dx dy is. We know that there's going to be a, over here, y cubed equals 8, no, x equals 8y cubed. We're going to take the derivative of both sides with respect to y. Derivative of x with respect to y is dx dy. I know it feels weird when you say that because you're used to taking derivative of y with respect to x. This is kind of backwards. It's okay. Totally works. 8 stays as 8. 3 becomes 3y squared. Yes, 8 becomes 3y squared, and then I'm going to put in the derivative of the interior, chain rule, dy dy, which is just 1. So dx dy, oh, it's divided by 8. Ah, fail. Fail, tragic. Hoop. Equals derivative with respect to y of y cubed divided by 8. There we go. And that becomes 3y squared over 8. And then we have derivative interior dy dy. The derivative of y with respect to y is 1. So we just don't worry about that. All right. So, but we don't care as much about dy dx or dx dy. We want dx dy squared, which is then going to be 3y squared over 8 squared, which is going to be 9y to the 4th over 64. Okay, we totally got this. So now our integral, our dy, so our dA equals 2 pi y cubed over 8 times the square root. I know this looks messy. Hopefully it'll clean up a little bit. We will see. 9y to the 4th over 64 plus 1 dy. Okay, we got this. We can do this. This might even be possible. So now we're going to take this. We're going to take the integral from 0 to 2. So we're going to take the integral from 0 to 2, and this is going to be the total area from 0 to 2, and I'm going to replace this delta y with dy. We'll go from a very small bit of y to an infinitesimally small y. All right, so I'm going to write this again a little prettier and slightly cleaned up. So I'm going to say this is equal to 2 pi over 8, which I'm going to rewrite as pi over 4, y cubed times 9 over 64 y to the 4th plus 1 to the 1/2 dy. All right, and we're going to go from 0 to 2. I'm going to try to do a U-substitution because when we take the derivative of this, we get something that kind of almost looks like that. I know, kind of an intuitive leap. We're going to see how this works. I'm going to say U equals 9 over 64 y to the 4th plus 1. Du then becomes 9 times 4 times y cubed over 64. So this becomes 36 over 64 y cubed. Oh, I forgot the dy. dy, there we go. dy, let's see, the factors of 64 are 2, and the factors of this is 4, so we can divide the top and bottom by 4. So this is the same as 4 times 9. 64 divided by 4 is 16. So it'll be 4 times 16. Y cubed. I guess I probably could have figured that out. That's okay. We're going to go with this. Dy, the 4's cancel. And now we want to solve this for y cubed dy. So 16 divided by 9 times du equals y cubed dy. and we have a y cubed dy here. We have a u here, so we're now going to rewrite this. Pi over 4 integral. I'm going to leave off the limits of integration because I don't want to convert to y to u. Not important. We'll go back to y in the end. So we have y cubed is 16 over 9 u to the 1/2 du. All right, that seems suspiciously possible. So this is going to become 4. This becomes 4 pi over 9. This becomes u to the 3/2. So you add, to do the integral, you add 1. So 1/2 plus 1 is 3/2. And you divide by the new number. So divide by 3/2, which is the same as multiplying by 2/3. And we're going to evaluate this from at 2 points. So now we're going to have 8 pi over 27. Don't know if I'm actually making life easier by writing that. And then we're going to place u with 9 over 64 y to the 4th plus 1 evaluated from 0 to 2. Maybe. Very possible. All right, so then we're going to plug in some numbers. 8 pi over 27. We're going to plug in 2. 2 to the 4th is the same as 2 squared times 2 squared, which is the same as 4 times 4, which is 16. So 9 times 16 over 64. 16 over 64 is 4. So this becomes just a 4th plus 1 minus 9 over 64 times 0 plus 1. Yes, that seems reasonable. No, because I forgot the 3/2 right there. There we go. 3/2. 3/2. So then we're left with 8 pi over 27 times 9 over 4 plus 1 is the same as 9 over 4 plus 4 over 4, which is the same as 13 over 4. So 13 over 4 to the 3/2 minus 1 to the 3/2. Yes. And doing some math here. So this just becomes 1. 13 to the 3/2 is just going to be 13 to the 3/2. There's nothing fancy we can do about that. So we're going to have 8 pi over 27 times 13 to the 3/2. 4 to the 3/2 is going to be 8, because that's the same as either 4 cubed, which is 64 square rooted, which is 8, or it's 4 square rooted, which is 2. 2 cubed is then 8. So 8 minus 1, which is going to be 8 over 8. So then we're going to have, our answer is going to be 8 pi times 13 to the 3/2 minus 8, and then divided by 27 times 8. The 8's cancel. And this is probably about as simple as it gets. Pi over 27, which is not very, times 13 to the 3/2 minus 8. And putting an actual number there because it's kind of nice sometimes. We're going to do pi over 27 times the quantity 13 to to the 3/2 minus 8. And we get an answer of about 4.52. 4.52, and that'll be square units. Does that seem right? That seems, yeah, might be correct. I'll say good, strong, maybe. All right, now, just to make sure that we're correct, let's ask an expert. All right, find the area of the surface generated by revolving around this. Submit. Bump, bump, bump. All right, A equals that. Area equals 2 pi r squared. Explain. Surface area generated by calculus with the limits of the integration of this. Yes. Please expand on the answer. To find the surface area, blah, 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 derive the... which simplifies to 4 pi over 3. So the surface area is 4 pi over 3. Yes. The area of the journey is, okay. I'm suspicious of this, but just to humor it, I'm going to put 4 pi over 3, get an actual answer, which is about, all right, so give a numerical answer for the area. We got 4.819. Is that even true? No, because 4 pi over 3 is 1.33 pi. That's totally wrong. Oh well. My fault for asking. Thank you. It's always good to be polite, because that way when the robots overthrow us, they'll assimilate me last. All right, so to backtrack what we did here, kind of make sure we got an idea of what happened. So to find the surface area of this, we found the surface area of each small segment going up. Each small segment was kind of like a hollow cylinder, but this hollow cylinder did not have straight up and down sides. It had slanted sides. So to find the length of these slanted sides, I call that dl. And so we ended up using effectively the arc length formula of each one. So we found the area of each segment going up. So we found the integral from y initial to y final, dA. We said then dA was, they're basically a cylinder. So I said, all right, 2 pi r times the height of this cylinder. Well, the height of the cylinder then, as I said, was the length, the sideways length, which means we had to use delta L, which was the arc length formula. So once we had the arc length formula, and then R was just the x value of our rotated shape. The x value was then given to us in terms of y cubed over 8. So we replace that in because we're going to integrate in the y direction. So we plugged in our value for R. We plugged in our value for the height of our cylinder, which is actually the arc length. And then we integrated. We were lucky that we were able to do a U-Substitution and math. And eventually, after we did enough math, we got an answer which was pi over 27 times the quantity, 13 to the 3/2 minus 8, which is about 4.52. So hope that helped. See you next time.